It's another lo-fi brainstorming session. So last time I introduced the idea of a stack of story graphs, and I've had time to implement that and do a little bit of refinement on it, including figuring out some stuff like how to push and pop from it from different parts of the story system, which I'm going to need to show you to explain in more detail. Because before I had some notion of where that would happen, but figuring out exactly which pieces carry the data and how each piece of data gets interpreted is a part of what I've worked on since then. And it's also a part of what's still not quite clicking. So it's what I'm going to look at when I start looking at the code. And then I actually have a second topic I want to get to in this brainstorming session. I think both of these topics will be shorter, and even I think the total of this might not reach this quite as long as the first three sessions have been, but I guess we'll see. All right, so here we're looking at some of the story graph construction code, and I'm going to go over it in a little bit of detail. But first, I'm actually going to take like a step to zoom out here. So if we look at the project's root folder, I now have all of the story graph stuff inside this folder called story graphs. And I don't know if I've covered this in any of the brainstorming sessions yet, but a big part of what I'm doing here is I'm hacking together a C textual interface to add authoring all this content so that I can avoid going down the path of making a content authoring tool first, because I think it's more useful to start by studying the runtime. The content editing for this is really just an editor thrown on top of a data structure, and there's a lot I could do to make that editor good by thinking of good visualizations and good commands and ways to work with it. And that's part of what I want to get to in the second half here, even is how ideas I have for making that good, and how that might impact what I need to do now. But for now, I'm building these things over here on the right. I'm building also the story fragments and all of that as just these little files, and I put them in these separate folders here so that I can have this, and it's not actually in the root folder here, but I have this bake script that is just scanning files in each of these folders and generating some includable files for the main program to deal with. And this has become a bit of a mess. There's definitely need to pass over that and clean it up, but that's not really a design issue so much as it's just how I'm hacking together the content editing for this system. And so I now have graphs going through that same sort of pre-processing. So each graph is like globally accessible to the whole program. It's a piece of data that is known and referenceable from all the other graphs and from all of the story fragments and from all of the code throughout the program, because it's getting pre-processed here. So I can forward declare all of the constructor functions like this one, and what happens then is like a global pointer gets constructed, and then there's an initialization phase where each of the global pointers, so like there's a QUG Act 1 global pointer, it gets initialized, passed into this where the data gets filled into it, and then is just available there because it's a global pointer from then on. And we don't need to get into too much of the details here of how that works. There's also these macros like state and path and stop, string, and gr push. These are defined specifically for these graph constructors as helpers. So I'm not really thinking of this as writing C code. It's just a data literal for this particular kind of data structure that I don't want to have to write an editor for right now, but I will maybe probably someday have to do that if this project keeps going well and I get to the point where I need one, right? Where I want to actually crank it up to that level. So the thing I want to talk about is some of these new things that are here. So this is the Act 1 structure. Act 1 is sort of the root level of the game's story graph, and it starts right here. So the first state always goes first. And the structure here is, here's the state. This thing on the right is the data attached to the node that sort of describes to the stack, the story machine thing, what to do with this node. So a stop node tells the machine to stop on this node and let it either do some computation or do some displaying to the user and gathering results from the user. the gr push instruction. Actually, this will be easier to show you if I just pull up the macros that define all these. So state and path define the graph itself. Stop is a kind of instruction I can put here that just says like, okay, we have some director procedure and some data and some size that we want to run from here. Stop string is similar, except it creates a director that's going to just display a single story fragment. So QUS intro is the story fragment. You might have seen this before in a previous brainstorming session, but a QUS is a story fragment. It just defines how to build one of these fancy strings. And so this is just saying like stop and display this, and you can see that within that it contains the instructions for interactable points. So there's like, you can click here to become the archaeologist or the beast slayer or the thief, right? And then another one we have is the gr push. So this is the part of the new system. This is a graph push. So here I'm referencing another story graph, and it's saying if you want to know how to run this node, it's not something you display to the user. Instead, it's an instruction to handle right away and to keep moving through the graph before you stop at a new node to display to the user. So here it just goes, oh, we need to display this to the user. Good, let's stop moving through the graph, stay here until the user interacts. Here it reaches this and goes, oh, there's nothing to display from this node, but there's an instruction of what to do next instead. And the instruction is to push this graph onto the stack. And then implicitly, whenever you push a graph onto the stack, you also set the current pointer at the top of the stack to point to the initial state of the new node. So if I show you QUG arrive in town, when we enter this state, we immediately push this whole graph on top of the stack. We don't actually put a copy of it on there. There's one copy of each graph, and we just have pointers that are moving through these graphs, moving through the states and the paths of the graphs, but the graph structure itself can remain singular. But anyways, we push a pointer that is an initial pointer on this graph on top of the stack, right? And it'll then be on this initial state for this graph. And we can see this has stop, so it'll then stop. This could have like a flow to another state immediately kind of thing if it did another gr push. We also have these gr pops, and this is sort of going the other way. So when you gr pop, you remove this from the stack and you end up back where you started. And you also send a code back. So here you can see we can either gr pop higher or gr pop the search move code, right? And so whichever one we receive here, what happens is, well, since we pushed this, this is, this took over. And these are sort of like the terminals. When we reach this stack, this graph is done, right? So we're removing it from the stack completely. This didn't end the graph. It just sort of paused the main graph and entered this one. So you can think of this like a function call, sort of, right? And a function call, when you arrive at the function call, the calling function, the one that started, the one that came first, doesn't cease to exist. It sits lower on the stack waiting for its chance to resume, and the called function goes to its terminating point, and then when it terminates, the one that called it takes over again, right? But when you return to that thing that called you, you send back some information. And in this case, the information we're sending back is information about how to flow through the graph next. Is how did this graph resolve ties to how to move through this graph next. So if I pop back this higher state or code, if I pop with this higher code, then when I arrive back on this part of the graph, it's going to go, okay, we need to handle this popped code. And we can see here that the in town 1 state higher has a transition path. So it picks up this as the handler for this pop code and moves us into the camp state from that, right? So if I play the game and I go intro, there'll be something to click there. That'll move you to here, which pushes this. I can move through this state graph. There's no content here after the first one has some content, then these are all blank still. And the last ones have some pops, which aren't content, but which flow us back over to here and then flow us either to camp or to woods 1, depending on whether we did hire or search, right? All right, so that's cool, but another thing comes up as it starts to get more interesting. So I come in here and I want to write this intro, right? So let's just follow through the process of writing. This whole video is gonna be a lot about the process of writing these things and how to make this as fluid and maintainable and manageable and intuitive as possible. And so when I arrive on this state, right, inside the arrive in town graph, it's got the stop string. So this is the string, the fancy string it's going to display. And as I'm writing this, I'm writing some introduction about what the name of this town is and what it's like, what role it plays, like what kind of, what it plays in the larger context of the world, and what it plays to you as a character. And then it tells you about your arrival. Some of this is incomplete and I haven't written all of it, but it tells you about your arrival. It tells you what kind of decision you're going to need to make. You're arriving and you're considering your next steps, and here are some things you need to get done, and here are the two choices you can make because you've arrived in the evening. And this is going to be a concept that I want throughout the game. So you can see I have here like a concept of evening. It's actually saying evening 2, which is funny because I probably had evening 1 up here at some point and deleted it. But there's only one evening in the graph now, so these could be like this, right? But you can see I have like this dawn, morning, afternoon, evening cycle, and then dawn, morning again. And that's because this is starting to step towards the ideas of having systematic gameplay stuff. So while the story is taking place over a certain period of time, and I want certain things to take a fixed amount of time when you get to them, other things so it's possible to navigate through the game story in such a way that you skip dawn and you don't wake up until morning. And same thing with this one. Things you can do in morning 1 and 2 are very similar, but they could be different because you might have different resources or different relationships. So the opportunities of what can happen in those are somewhat dependent on what it means to go through the morning state, but it's also going to mean different things depending on other aspects of the game state and maybe special aspects I want to plug in. And in this case, there are special aspects I want to plug in because you arrive on the first evening state. But I didn't end up keeping that there because I want to have slightly tweaked behavior at that point. So you can see I ended up with this idea that I'm going to have these evenings, and during the evening, you're going to have a few different decisions you can make, and I'm going to have a way of writing out the list of your decisions. But I want the list of decisions to be a little different in the case when you're first arriving in town. And it might be that I want them to be different a lot. Like I might specialize this text in lots of ways throughout the game. There might be different pieces of text that I want to be able to say, this is a systematic decision that you're going to get used to, but the flavor text is going to look a little different here because of a special context in which this particular decision has arisen. And in this case, you've just arrived in town and you haven't even begun your adventure really properly yet. So there's this idea that you're not just going to go to an inn, you're going to get lodging at an inn and begin preparations. Now, once you've done this, in the future, this will just be called like go to the inn, right? You'll already have arranged for your lodging. You're not going to have quite the same language for describing this. And similarly, you might have different, you might have different language for describing the visit a tavern thing. This is a little less maybe in need of being tweaked, but the way you would describe going to an inn if you were just writing a book for the first time wants to be different than if it sort of becomes a common thing. And I talked about this before as an idea of progressive text, and I could do this as a progressive text thing, but this also isn't just progressive text. It's also tying in with the language I used in the previous writing up here. So talking about this process of writing, I'm writing this stuff and then I write these options and I want them to feel like they match with each other. But I want the choices I'm making here to feed into a systematic piece of the game. And this is, when you're making something that's systematic, having a lot of variety is trickier. It's not that it's impossible, but you have to think about how to achieve the variety. Because systematic things like to be repetitive. They like to run the same way in all cases. That's what makes them predictable. That's what makes them an interesting game system to learn and master. But it also is what makes it hard to not make the text feel dry and clunky. And I'm trying to get past that limitation here. And so I'm thinking, well, if I'm going to end up having this graph, so I have a third graph now, right? And it's the graph that describes what happens in the evening state. So just to clarify and back up here, you could imagine that what would happen is like if I just had an evening here, or if I look at the evening here, these might be places where I have a graph push, and I push on the evening state, and the evening state is another, or the evening graph is another graph that describes a couple of options you have. Now the evening graph here, you can see basically your options are you can go to the inn right away, you can go to the tavern right away, and then if you go to the tavern later, you're going to go back to the inn anyway. So this is like you can go early or you can go later with a visit to the tavern first. And then there's 2 different times you can wake up. And the graph doesn't show you this, but the game's logic is going to enforce that you only get to do early wake up if you went to the inn right away. If you stayed up late and went to the tavern to see people, then you don't wake up until, well, like later into the morning, right? So that's the game mechanic I'm looking for, and I want to encode some of it into the graph, but I'm not trying to encode literally all of the programming in the graph yet, or pretty much ever. But the graph by itself isn't enough, at least. I need to encode it with the graph plus some outside game state stuff, because I want things that wouldn't just be a state machine, right? I want things that run parallel to the fixed state machine story graph flow. So this would be controlled by that. I could encode this into the graph by having 2 different in states and then having 2 different transitions. And maybe there are reasons why I should want to do that, but that's not really the topic for today. It's an interesting topic for thinking about in the future if maybe I need better graph construction primitives so that I can achieve that kind of thing. Not worried about it yet. The bigger point here is you can look here and see I've got this inn and tavern state and I have a begin state. And now if this becomes a reusable graph, it might be the case that, later on you start going through the story and having a number of times where you're back in town and the evening time comes around and you make this similar sort of decision again. And when that happens and it starts to become familiar, having some rote text that shows up every time might not be the worst thing ever. There might be cases where you're like, I wish this could be more context specific, and you have to think, choose between, do I make it context specific by making begin sensitive to context, or by doing what I did over here, right? So one option, let me back up and explain this a different way. One option for making the beginning of this state context sensitive is to just say, hey, whatever string builder you put here, it's going to read into the game state and pull out whatever it needs to figure out which string to show. And so if you end up having like 5 different special contexts, there's the beginning of the game context that's unique, and there's, you arrive in the evening, but you are broke, and so you don't have money to go to the tavern. Whatever, you get your regular version, or, some other special story stuff might come up, whatever. You could imagine just going like, okay, if we're in this state, render it this way. If we're in this state, render it this way, and so on and so on and so on. But that kind of forces you to organize. That's not just a way of achieving this. It's also a choice of how to organize the information. And as I'm talking about this, what is the writing process like? The writing process does not want to have pieces of relevant text spread out that are all supposed to go together and sound nice on the same screen. That makes it feel very hard to get everything to line up and go together, and it becomes much easier to just phone it in and write some dry text that is clunky in pretty much all scenarios, but sort of gets away with sort of functions, right? And I want to avoid giving up on making the text sound right, and I want to be able to make it do more than function, right? I want it to sound like it was written a little bit intentionally. It might eventually have places where you can see the repetitive structure, the repetitive patterns, but even when it's doing that, I think it's possible for it to do that in places where it feels appropriate, and also it's possible for it to do it in places where you feel like, wait, why couldn't this have been adapted in context? Like in this special case at the beginning of the game, you couldn't write a special intro to the evening. And so I want to be able to do that, but doing it by overriding the string builder here, it's a weird flow because most of the language is right here. And if I tweak the language here, that tweaks the thing that I need to flow into, right? If I change, like, I move the paragraphs around and I change the order of things, I kind of might want some parallelism between the word choice here and the word choice here from a writing perspective. But if I have them not even close to each other, in the content, like in the data structure, right, then it could be very easy to miss that. And I could think of that as a tool problem. Like, oh, I'm going to need a tool that links these relevant concepts up. But how often do you actually get really good tools that do the magic that you imagine when you wave your hand like that? I haven't found that that works out. The magic happens when you plan for how these things will actually link up in the data structure from the front end, right? From the beginning of the process, not as an idea of like there will be a feature that I'll add to the editor that'll automate this. I just don't buy that these days. It doesn't sound like I'm solving the problem. It sounds like I'm hoping this problem will go away. So the new idea here is there's a different way I could override this, and that's to push a graph from a payload, right? So I could say, earlier I was pushing graphs from the state. So you got this machine, and I haven't showed you the machine yet, but the machine runs when you say, here's a node, and it looks at that node and goes, okay, what does this node want me to do? That node might say stop, and then the machine stops. But the node might give an instruction, and that instruction can be to push a graph. So that's one way that pushing graphs has happened. Now I'm introducing a new idea of how pushing a graph can happen, and that's from a payload itself. So if we look at what this lets me do, I have arrive in town, and it's saying, okay, when we arrive in town, this is the special graph that describes your first experience in the story of being in town, right? Every time you play the game, it starts with you arriving in town. This is how we generate that, render out that part of the game. And as we render it out, I write inside of it, right? So here's arrive in town, here's the descriptions of things, and here are the buttons that you're going to be able to click. Here's the interactive piece. And so this is not a part of a reusable systematic thing. It's hard-coded, but I want it to then flow through the systematic system that I like, the systematic pieces that describe evening after that, because I don't want to have to duplicate the whole evening structure. And if after this I would need to put in more stuff to continue to make it feel like it flows, that'll start to get more frustrating. But I don't think it would come to that. I think that from here, something like the progressive text I talked about could take over, right? So if you get lodging, well, this is the first time you're talking to the innkeeper. No matter whether you do it now or a little bit later in the evening, maybe your first encounter with the innkeeper will have them saying the same thing, right? They'll give you their first greetings. That's just like the progressive text. There's some other ways I have ideas about how that might go, like the idea of parallel state graphs and stuff. But let's not go down that path yet. That's a little bit farther down the road still. So the idea here is I have this evening graph, and I've rendered out from here. So let's do this step at a time. We're inside the arrive in town state. We're at the beginning of that. This is rendering out. Here's a button. Here's a button. What this button wants to do is say, when you click me, I am going to enter into another graph. I'm not going to give you a flow from this intro to something else in this graph, because if I gave you that, then because what we want is to take what's in the evening system and chop off the first state and put the rest of this in there, we would end up, if this grows to have like 6 or 7 options, we would end up having to put all of that into this spot here and have it duplicated and maintained in parallel. So I'm trying to think of this from the programming perspective as well, right? We're building a thing that where you program a story, or you write the game logic, right? Your programming and writing is fused together. So I don't want unmaintainable structure problems any more than I want untenable writing synchronization problems, right? So the idea is when you're inside this arrive in town state or graph and you're here, what we really want is to render out some special text that only happens here at the beginning of the game. And we want the buttons in that special text to kind of flow you into an evening state. And I could have almost put an evening state here and just had that evening state push a graph itself. And the only problem with that would have been then this here has to basically end with, okay, you will need to, here's a special description of your situation right now and a continue button. And the continue button then flows you into something that's like, it is evening. You could do this. You could do that. You're in town. It is evening now. You can do one of these things. It feels like you just got dropped. Like you were being told a story and then it just dropped you, right? So I want to play with this idea that I can from the payloads themselves say, hey, this was some interactable thing, but the way that the player interacted with it means that instead of flowing forward, the next action is to push a graph. Now, let's get to the next step of it, what makes this interesting and why I need to talk through it. This is actually working. So when the payload gets processed, we grab the story machine, we read a story graph pointer off of the parameter block, and we push it onto the machine. And that works. And the issue is once we've pushed on this evening state, I do end up where I want to be. So, I mean, this might be a bit off, right? Right now, what I'm doing, this is worth talking about, so let me slow down and talk about this part. Right now, what I'm doing is I'm first setting up a payload to push a story graph onto the stack, and then I'm setting up another payload to move in that graph. So I'm saying, hey, I'm going to use the evening graph, and I want to automatically make the decision to go to the inn, right? Now, that's not really that bad. We're basically saying hide from the player the fact that we began this evening state and didn't show them that. We preemptively figured out what they were going to do in that move in this interface and consumed the input here and then passed it on to the evening graph. That's fine. I'm not actually thinking that that's a bad option for how to do things. I do think there might be a good alternative way to start doing this, which would be right now every story graph has a special initial state. And that is useful for a couple of reasons. One, I already have the restriction that like getting these story graphs declared in a way where I can see all of them globally is hard. It'd be a lot harder if I also had to figure out a way to make this like list of states all visible, right? If I had to say, okay, QUG evening begin and QUG evening inn and QUG evening tavern are all linkable names so that I can then take that name and link to it from right here. The upside to that would be that you could then say basically, okay, we're going to push a graph and I'm going to give you a pointer to the node in that graph. Like I could give you, here's the graph to push and here's the node within that graph to start on. You could even go so far as to cut out the graph at that point, since you could uniquely determine the graph from the state pointer if you wanted. So that's cool, but it's real hard to hack that through the C code thing that I'm doing. Now, if I had a data editor, right, then we could just say we're going to export names, linkable names for all these things to whatever whatever linking process that's going through. This is just as hard as linking the story graph itself. But because of the fact that these are executable statements here, the next step to making this even more of a data structure and not a piece of code would be to do something like this, right? And then you could start to imagine like, oh, we could scan the states and make sure that the name of each of those is available in addition to the name of the thing itself. And like we could go that far. I'm hesitant to hack, but it is kind of the nature of this. So maybe that's something worth exploring, is saying, why don't we just go ahead and keep hacking on the way we specify these data structures for now to get them to have all the properties we would like them to have so we can experiment with them properly. But that's just a smaller thing. It was worth chatting through that because after looking at that, I think it's doable. It's just it gets nastier and nastier, and I'm getting less and less comfortable with hacking this hard, but I think it might still actually be the right call. I need a little more time to feel it out before I go for it, but yeah. So that's one part of the issue. But there's a much bigger issue. So let's now switch over to the story machine itself. And I've saved this for last because this is the sort of heart of the system. So I've described intuitively how it works, but here's how it actually works now. We're like literally looking at the code that makes it do what I told you it does. So there's a story machine thing, right? We can construct one. Resetting it is just so that because this allocates it, actually it creates an arena that is set aside for just the story machine itself. And so you don't want to allocate a new one every time. The reset just clears out all the data, sets it to an empty machine, but keeps the original arena. So you don't have to free it. You can just reset the state. Then the other thing you can do that sort of there's a little bit of cleanup work probably to do here. There's the push, which lets you put a new story graph onto the machine. There's pop, which takes one off, and you can also ask what's the current node we're on. So the stack, what's in each layer of the stack is a story graph coupled with the current state or path that we are pointing at within that graph, right? So the story graph is a directed graph of states with arrows between them, and at any given time, either one of the states or one of the paths is selected and that is repeated at each layer of the stack, right? So this lets us ask, what's the current node pointer at the top of the stack, right? What's the one that we're like, just like if you're running a piece of code that has functions and a call stack, the thing at the top is the one that's like the next instruction you're going to run. Everything below that is what you would run if you were to return to it, but you're not actually running that stuff because it's sitting there sort of frozen. So this is the one that we're actually running currently, right? So what happens here is the way the machine updates is you send in a path code, you send this code into it, and it uses the current node, so the top of the stack, the state at the top of the stack, together with the new incoming code to update what the current node is. And along the way, that can do things like pushing and popping the stack and working with the directors that live on those nodes. And those directors, big surprise, those directors are the big problem still. They are the abstract piece that I threw in there to kind of get me going. It seems like sometimes when you don't know what exactly to do, you reach for an abstract thing just to get you putting something in there. And as soon as you hit a wall, you fix it by unabstracting. And that's an interesting pattern that I've been using in this project. I don't know why, but maybe it's not a bad approach as long as you don't think that the abstraction was a good thing. And you just remember that the abstraction is actually your lack of understanding encoded into the problem. So maybe what I want to do here is read through this, show you how it works, and also point out all the places where there's a director involved and why I think there needs to be a director there right now, and how that might be a understood as a lack of understanding, an unanswered question that I am kind of trying to kick the can down the road on for now. And so maybe by exposing those, I will force myself to answer the questions that are unanswered somewhere and make the ideas clearer. So what happens is we come in here, we start at the top of the stack, we grab the state pointer there, and then we're going to figure out where do we move to from here. And now there are two kinds of nodes. There are states and paths. So remember, the whole graph is a directed graph of states with arrows between them, and the arrows between them are called paths in the system. And both of those are nodes, right? So you have some nodes are states and some nodes are paths. They're all nodes. And so your machine can actually have either one selected, but whatever one it has selected, it always has a node selected. So then what we are doing is we're looking at what kind of node do we have. If we have a state node, we have this rule for updating it. And what this rule is doing is it's taking the path code and it's scanning all of the paths that leave this state, right? So each path connects two states, and it's an arrow. So an arrow can leave a state and it can enter a different state, or it can enter the same state, right? But a path has two endpoints. And so when you're in a state, there are some paths. It could be zero paths, by the way. There are states with no outgoing paths. But in this case, usually what we're thinking of as is a path code is telling us which path to take. And so this is taking the current node as a state, right? here, and the current node is a state, and we're looking at its paths and picking one, and this is the path node, right? So this is a state node, this is a path node, and it's the path node that matches this path code, okay? And then the other rule is if we're already on a path node, there is the code can be ignored. There's only one way to flow forward, and that's to go to the destination. So a path has a source, like a starting point, and a destination point, or a beginning and an end point. So this says just go to my endpoint. Go to the state node that lives after this path, like at the end of this path, right? And so this takes us from a path back to a state, okay? Then this is the first time we talk to the director. So the idea here is we're now trying to keep track of whenever we've left a node. So we were on a current node. When we leave a node, if a node has a director attached, that director can have a notion of initializing and cleaning up some state. And that state usually is actually state living inside the game state, so it's not coupled in with the node or the stack or anything like that. And so we need to explicitly, there's no custodian for it. We need to explicitly init and clean it up. And this is completely abstract in the sense that directors can be implemented in many different ways, so we don't know here what we're calling. We're saying whatever this director is, do its cleanup. And that can be lots of different things. And the reason I feel like I need this is because I want the directors to be things like game loops that are not story graphs necessarily, right? I imagine that there's going to become a point along the way here where a story graph won't describe very well the structure of gameplay that I want, either because I'm going to want like random spawn tables to take over, or I'm going to want something like a permutation decision problem. So what I mean by that is right now we are deciding what comes next by choosing a path on a graph, but another way for the player to kind of interact with what comes next is to say, like, okay, there are 3 things that are going to happen, and you're going to order them, like which one's going to happen first, what's going to happen second, what's going to happen third. And that can create a different sort of dynamic of how to systematize things that's a little bit more systematic than a story graph, because you can learn, like, okay, this thing in the third slot means this, and this thing in the second slot means this, so I think I need this one in the third slot. And then, you work out, like, and the bigger the permutation gets, the more interesting the puzzle gets there. Or rather, the strategic options, depending on what kind of game you've got, right? That is a different style of decision making, though. It's a different style of system. And so I don't want to have to, if you look at, say you have 5 options and you're going to permute them, that's already 5 factorial paths through a state graph. I don't want to manually code a state graph for that. So comes a point where it's not clear that you still want a state graph in charge. Now, that could end up being wrong somehow, but I haven't seen any, like, I'm not yet gone deep enough to find out that state graphs can just take you all the way and that you never need the state management stuff. So that's mostly there because I haven't gone far enough yet to rule out the possibility that these game loops need some independent state construction and cleanup. So I just need to keep going farther into the game construction to figure out that part. Okay, so then we get to the heart of this thing. So far what we did, we looked at the top of the stack, we figured out what our next node was going to be. If we've updated the node, so if there is a case here, I skipped over this, there is a case where the node doesn't change. If this path code doesn't actually identify any path that leaves the current node, then the next node stays on the current node, and so no cleanup happens because you haven't actually left the node you're on yet. And it's sort of a bug, but it's a gracefully handled bug here. I don't want the game engine to crap out. I just want the game developer to go like, oh, it did something wrong. Like, I must have made a mistake, but it didn't look like it did something so wrong that it's like incompetently constructed or ruins the whole gameplay. You just got to like take a different path that doesn't have a bug, right? Okay. Here's where the main bulk of this happens. So once we've figured out what the next node we're going to is, we then have to look at that node and see what's on it, because just moving one node isn't good enough. The next node that we move to might have a rule attached to it that causes us to move again. And so what we do now is we kind of treat this like a virtual machine, right? We're taking in instructions. Those instructions are telling us how to update the state, and then we are following those instructions inside the switch and seeing if we keep going by moving our state pointer forward through the system. The difference is, instead of decoding a bytecode and having things like jumps and registers or stack pushes and pops for values and arithmetic, what we are checking are rules about how to manipulate the stack of story graphs and how to advance forward through the graph. Okay, so let me take you through the details. The first thing we do is we look at what kind of director we have, because it turns out that even though I said a director is this nasty abstract thing, it turns out that we all it's only a nasty abstract thing some of the time now. There are some times when it's a pretty concrete thing. So before, when I first made a director, all it was going to be is a way to display content that was not just a fixed string, but that was like a more complex program that might run, like a mini program or something. But it turns out that if you have content attached to you, that is sort of excludes the possibility that this is a node that you don't stop on, right? When you're doing this iteration through the graph and doing things like, oh, this node wants to do a push automatically or a pop automatically, those pushes and pops automatically should probably not also have some story on them, because it just doesn't make sense to me. Like, I'm not sure how, like, as I am expressing it, it feels very natural to say, oh, in the in town state, I want to push the new graph, and the new graph has the content. The in town state, right? Let me show you what I'm actually referring to here. If we go to the graph for Act 1, right? This in town state where we do the initial push, that doesn't need to have content on it. The content's inside the arrive in town graph. If I put content here, I could imagine maybe thinking like, oh, we're going to put content, and then when we're done with the content, we'll push. But the content itself has the ability to contain options, and those options can also do changes in the state. And so it feels like you don't want changes in the state that can be encoded here and content, because content also implies changes in the state. So this is like a way to make a change in the state is to say stop here and get the user to make a change in the state. And this is don't wait for the user to make a change in the state. Just do this particular change in the state right away, right? So they're kind of like mutually exclusive in the design that feels most natural to me. And so a stop is the abstract one. A stop is the content that you want to show, and that can be an arbitrary game loop in my mental model right now. It can also just be a simple fancy string with some options, right? But graph push and graph pop are not abstract at all. All a graph push is it's, graph push here, this is null, and the data points to the story graph that we want to push. And the graph pop is a graph pop here and a code to send back, right? So they're very concrete things here. And so now what we're doing to process them, grabbing a director kind, and we're going to decide based on two factors. Well, one, what's the director kind? And sometimes we also look at what's the node kind of the current node, right? So you have it, which is the node that's currently sort of at the top of the stack that we're holding locally. And we're going to look and see, okay, if we have a director kind of a certain kind, like here's how we handle it, right? And we have 4 different kinds, we handle them. And if we find a stopping point, so that's if we find a stop here. If we find a state, even if it's null, so nulls are for if there is no director attached. Paths that are null are just assumed that you advance past them right away. But with states that are null, we assume that it's we don't know how to advance past it, so we stop there. And even though there's no content to display, there's a fallback for showing some developer info. So it wouldn't be something you would want to take advantage of in a final game, but it's a useful feature in the runtime for while you're developing, right? So you can make incremental progress without having, you don't have to finish the whole story just to make it a valid story that you can run through the system, right? And here, if you have a stop, you just stop right away. If you have a graph push, not a big deal. You just push a graph and you update the iterator that you are holding locally to be whatever when you do a push here, it uses that initial state. Remember, each graph has an initial state. So right now this is just saying, oh, do the graph push that is encoded into the director, and look at our new active node. It's whatever's now at the top of the stack. Now, after a pop, we do have a special case here this isn't a problem. It's a potential bug that your game can have on this engine, which is that you popped more than you should have. You can always have mismatches between pushes and pops by accident, but if you pop too much, you end up with an empty stack, and that puts us in a particularly difficult to recover from kind of issue. So I'm just taking extra care to okay, if we pop it to an empty stack, we got to get out of the loop, because we're going to null dereference real quick if we're not careful. And if you pop and there's still something there, again, we read off the top of the stack where we're at now, and then we have to figure out how to finish the pop. So we've popped the stack, but we also want to apply the pop code, right? So the pop code came back. Let's look at the example again. The pop code comes back from funny enough, I attached these to the paths instead of the states. It works the same either way. But I think I actually meant to arrange it like this, and for some reason I did it in a different way. It doesn't matter super much. Technically, that other way I did it would have been run a little faster, since I don't have an optimizer here, removing the extra logic. But so if we reach one of these states, right, it's going to pop, and then it's going to have this code to deal with still. So once the stack is popped, it has to apply this code after the pop. It's kind of like a return. When you return, you pop the call stack, but the caller has to do something with the returned value still, right? So when we get back to the caller, they're the one who decides what to do next given what was returned, right? That's not determined by the callee. The callee just got you to the point of generating the value. So similarly, this evening graph is going to tell you whether you wake up early or wake up at the regular time, but it's up to whoever instantiated this instance of the evening graph to have a plan for what that means now, right? So we are starting to see how systematic things will be pieced together, but placed inside of larger contexts where they might have different implications, right? So that's cool and exciting, but I'm having a little trouble implementing it. And this is the real meat that I needed to get to today. When I have this pop code, if I got a graph pushed from a graph push director, it's easy, right? It just works. So let's go look at the example again. This time we're looking at the arrive in town graph. And you can see when we go to, let's look at the Act 1 graph. That's the right one. Yeah, so there's this in town state. And when it does a GR push, that just works, right? So that push happens. And if we were to get to one of these states, what would happen is it would go, oh, we've got a pop, and it would look here and go, okay, so we've come to a new director. So this is not the director kind. Up here we have a director kind of where we started, but after the pop, there's a director where we popped to, right? And that director is going to actually be the one that tells us how to handle the pop code. So it's not the one that tells us to do the pop is like a return statement. The return statement doesn't tell you how to handle the return. It tells you what to return. The one who tells you how to handle it is the one who did the push in the first place, or the call in the first place, right? So this one is going to go, oh, well, okay, here's how you handle it. Whatever they told you to do, just go ahead and select that path. So this is just like saying, okay, they've popped to me. Whatever they popped to me is the path code I should use to update my state now. So if they popped to me that I should wake up early, or in town, right? So if the in town ends with one of two things, either you decide to hire guides or to search for the dungeon by yourself. So whichever one was specified in the pop then tells you whether you go to the camp state or the woods 1 state from in town 1 in this graph, right? The pop from the other graph arrives here, It actually arrives in this code here, implements this, but conceptually it arrives here and flows either to here or here through one of these paths, right? That's the idea. And that just works because, here's the iterator that points at in town 1 after we pop, and it's got a graph push state director type. And so it handles the pop code by just looking up what's the next it and selects that. And then, that puts us on a path node. And then we just keep running the machine, right? The machine is a loop, so it just goes to the top and keeps processing. It goes, oh, I'm on an empty path. So I step forward again, and this machine just keeps going until it finds a place where it should stop. And so as soon as it does this, it's pushed us down the right path of handling for what should come next. What's not working is when I have a stop. And this can happen because of things like this, right? If I have this piece of content, that content isn't a special kind of director. It's just a stop director, right? And it's a stop director whose logic is basically render the string and that's it. Except I wanted I put here that directors would handle pop codes in special ways. Why did I say they would handle pop codes in special ways? Well, I was thinking that they would. If it's a game loop, right? If the director is a game loop that's doing like random events for a little while, like it's going to generate a certain number of random events before it lets you finish the story state, and you have to pass the challenges that come up in those events, then it's possible that those events will generate, when you generate a particular event, that you will want to play that out by pushing a new graph onto the stack. And then when that graph pops, you're not going to want that to be interpreted as flowing away from the state, right? If my goal is to have 3 random events, then if on the first one I push a graph onto the stack, and then that graph pops back to me, if I have to interpret that as flowing away from the current state, then I can't have 3 random events here, right? So my game loop can't say that it's arbitrarily gonna make there be 3 random events. And, if that wants to be n random events, right, it doesn't have to be a fixed number. It might be even clearer that this is hard if you want to imagine like something completely different from a story graph. Like it pushes that down and now it drops you into a strategic game or some other mini game that has to happen that is sort of open-ended. But somewhere along the way, that triggers something that you want to process through the state graph, the story graph, but you don't want the popping on that story graph to be misinterpreted as ending the entire state below it. It's just feeding back information to the state below it. So I thought that there should be a director way of reacting to the pop code, right? But the problem is how to incorporate this into the whole machine, right? So let me show you sort of where I hit the dead end. I have this arrive in town. It's doing the arrive in town string. The arrive in town string is trying to do that whole trick where it uses the evening graph. So the payload system is being used to push something rather than the director directly, right? It's not like I have the story graph node doing the push. It's the interaction from the player that's instantiating the push. And so now I'm running into this problem because the thing that the director that was sitting there creating this was this guy. And whatever I put here, it can't update the iterator of this. Now there's some ways I could do it, right? I could say afterwards that you need to read off of the top of the stack, right? And then just say the director can just mess with the stack pointer itself. So if the director decides to do that, then it's deciding how to advance the system, right? It could decide that its reaction is to push a few things or to set up the flow itself or to completely obliterate the stack and construct a totally different state machine, whatever wild thing that makes sense for the purpose, right? And then here inside the loop, we just read it off and go, oh, okay, we're up to date again. Whatever that thing did, here's what we do now, right? So that's an option. And as I say that, that doesn't seem like such a bad solution. Some other ideas were to say like it could return where it wants to go to. But the issue I have with that is what if it wants to push or pop? What I hadn't thought of before is if you do it the other way, if you do it this way, you know, until I was talking through this I hadn't thought of this, but this just seems to actually solve my problem now that I'm looking at it, right? I was thinking this was going to have to be like, either I was going to have to extract this. So the other idea I had was to say like, oh, if we reach this, then we're going to stop, right? And we're going to like, result pop code or something, right? We're going to send this pop code out. And so then we go like, oh, we got to stop. And we get outside of the loop and we do this, more director nonsense. And then the result pop code could maybe be returned from this whole thing. So it'd be like, oh, we had a pop code and it landed on a director. And so we had to get out because a stop director, we can't process it inside of the loop. So here's the result pop code, and then send that to the director, and then still, I think it just sort of kicks the can down the road, right? Because then it's like, oh, what if that thing then wants to resume processing of this loop? Like the director itself is going to call the machine move thing or something. Like there's that, maybe, I don't know. But I think the right thing to do, now that I've talked it out, now that I've looked at it this way, is to think of this, like when you're building a virtual machine, let's take the perspective of this is a virtual machine. You get to points where you want to have external function calls, and the director is pretty close to that concept, right? So if you're building a normal virtual machine with bytecode, you build in some operations you want, like pushing on your value stack and adding two things off your value stack and multiplying, or you have registers and you're adding and multiplying those things. You're doing memory reads and writes and whatever. And you have a call stack built in, maybe whatever you want. You have all that cool stuff. And then you go to points where you go, okay, I just want to be able to do something here that I can't implement in the bytecode, like calling to system layer stuff to do graphics or to render out audio or to generate a file handle that I can write stuff to, right? Whatever the case is, like eventually you need to do something that bytecode won't be able to do, because bytecode by itself isn't sort of speaking the right language to go to the operating system or to other low-level things. But you can just write a function pointer. You can just write a function and have its function pointer match the state machine, the virtual machine, expectations for like foreign functions or external, what's the word, like just like built-ins, right? Built-in functions. And then you just have an opcode that's like call built-in function and a number, and the number just tells you which of those built-in functions that you've generated for your virtual machine should get called right now. And then that function, how does it work? Well, it gets a pointer that represents the state of the machine and can do whatever it wants. So it can do magic, like inspecting the state of the machine and doing things that couldn't have been done within the context of the machine, but can be done within the context of the low-level system. So I'm thinking this is the same thing. This is wrong because I'm thinking of it as contained within the machine, and really I should be thinking of it as a helper in implementing the machine. It is completing the implementation of the machine. It is providing a built-in function that can't be expressed in the graph system itself. And that built-in function can do things like random number generation, looking up things in the game state, complex reasoning about data structures like permutations and other whatever else I want to do to make things systematic, inventory systems, whatever, things that wouldn't fit into the story graph very easily. And it can do all that and then provide its results as manipulations of the graph machine. So I think that is the right way to move forward with this. Now, I said I had two topics. It looks like I ended up using more than enough time just to talk about this one. There is one minor topic that I would like to fit in here, which is as I was looking at this, I realized that this cleanup and init thing is even more busted than I even realized. So here's the good news, is these don't actually do anything. Like I don't have anybody implementing the init case or the cleanup case yet. So I think maybe the right thing to do with that is to pull it out and just say, like, if I end up needing something like this, then put it in and put it in right. But this is clearly wrong. And there's a couple ways that it's clearly wrong. This is saying that we init and clean up a node whenever it's not at the top of the stack, basically. And like we clean up the only node who's, how do I want to say this? The range between the init and cleanup is determined by when this node is active. And so when we come in here, you can imagine I'm at the bottom of my graph, right? We're in Act 1. And maybe here we have a director somewhere that does some init. And then it pushes. So say we go into the dungeon with the guides. And so that initializes some, dungeon state, maybe, right? And it's going to do some random encounters. And then it generates a random encounter. It pushes something on the stack. Well, this is going to then clean up the director for this state because it's like, oh, that's not selected anymore, even though we still are doing it and need it. So if this is even a useful concept, this is not the right way to implement it. So I think the other thing I can conclude is this is wrong and this is wrong. So those are going to go. This is not wrong, but I need to tweak it. The correct thing to do here would be to say, I need a concept very similar to a built-in function, and directors that are stops work as built-in functions when we land on them in this way, right? Similarly, I might want that here, right? So a stop right now is a stop in the sense that we stop there and we go into content display mode. It's conceivable I might want to say built-in functions could mean when you arrive at a node, do something that is a built-in function. A built-in function might mean when we pop back to a node, do something that is a built-in function. And we might want to have one definition of a director that carries both of those. So it does something fancy when you arrive there, does something fancy when you pop back to it every time you pop back to it. And it might also want to do something fancy to display the content still. So I think those ideas might still be useful to run with. There might still be reasons why I end up not needing the abstraction, but I do think that something like a built-in function type of approach does make sense because you end up with that in a virtual machine, which is sort of what this is turning into. And so I think having this be analogous to built-in functions is the next big step for me to make progress with. So that's it for this time. I do have more thoughts, but I'm probably I'm gonna have to do them another time. And those are thoughts about the editing process and designing for that. But I think that I have more than enough to work with just from this session. So I'm gonna stop here, save those thoughts for another brainstorming session. Later.